Okay, in this lecture we're going to talk about looping. So looping allows us to repeatedly execute the same block of code over and over again. Okay, so let's say I had a program where I wanted to print out my name repeatedly, maybe 5 times. So this would definitely work. I can, on 5 separate lines here, do a cout. And if I run this, you'll see, yeah, it definitely does print my name 5 times. Okay, but what if I wanted to print my name 10 times? Well, okay, I suppose I could go and copy this code and paste it down here and run it. And we should see my name now 10 times. Okay, but what if I wanted to print my name 1,000,000 times? Okay, that's a lot of copying and pasting. That's probably not something we'd want to do. Ideally, I would like to isolate what I want repeated, the printing of my name, and then tell the computer to repeat that action many times. And when we tell the computer to do this in a program, this is called a loop. So without a loop, the physical order of the statements is the same as the logical order that the statements are executed. In this case, from the top to the bottom. Each one of these statements gets turned into one or more machine instructions that live inside this thing called an executable program file. So if you're a Windows person, we call these executable program files EXEs, because that's the file extension given to every executable program. If I needed to print my name like this, and I copied and pasted that cout 1,000,000 times, it would result in a much larger executable file than if we had just used a loop. Okay, so let's look at the syntax for this thing called a while loop. Okay. And we'll see there's a keyword while, and then we have inside parentheses this logical expression, and then we have this block of statements that come after the while. Okay, loops are similar to if statements in that there's always this logical expression that the computer evaluates to be either true or false. Now when the flow of control reaches the while statement, the logical expression is evaluated by the computer. If the expression evaluates to true, then the flow of control enters the block and all of the statements inside that block are executed. When the flow of control reaches the ending curly brace, when it reaches the end of that block, the flow of control returns back to the while statement and that logical expression is evaluated again. Now if it evaluates to true, the entire block of statements is executed again. Okay, and then when we come to the ending curly brace, we go back to the top and reevaluate that logical expression. When the flow of control reaches the while statement and the logical expression evaluates to false, okay, the flow of control jumps to the first statement beyond the block. Okay, so you have to kind of imagine the flow of control when it reaches here. We evaluate, or the computer evaluates whether that is true or not. If it's true, it executes the entire block of code. And when we come to the ending curly brace, we always go back and reevaluate and reevaluate. Right? As soon as that logical expression evaluates to false, right, when the flow of control is here, that's when the flow of control would pick up with the first statement beyond the block. Okay, so let's look at some actual code here. Let me replace this with the equivalent code that will work with a loop. Okay, so I'm just going to run this and then we'll talk about it. Okay, so you'll see, yep, my name did get printed 5 times, and if I wanted my name printed 10 times, I could just do that, and so on. Okay, so what's going on here? Well, the first thing we see is that we have this variable called count. And this is an example of something called a count control loop that we'll talk about in more detail in a second. Okay, so we have this variable called count. So let's kind of draw our memory here. And we have this box called count. and we've initialized the value for that box to be equal to 1. Now when the flow of control gets here, like we said, the computer evaluates this expression. Is count, is the value 1 less than or equal to 5? That's true. So we're going to go inside here and print out to the screen, okay, my name, and then the end line. And then we're going to say count is equal to count plus 1. So remember these assignment statements. You evaluate the right-hand side of the equal sign first. So count plus 1 is 1 plus 1 or 2. We're going to store 2 back inside the box called count. Then we're going to come to the ending curly brace, and that means the flow of control is going to return back here, and we're going to say is count less than or equal to 5. Is now 2 less than or equal to 5? That's true. So we'll print out my name again. Okay, and we're going to add 1 to the count. So 2 plus 1 is 3. We're going to store that back inside the box called count. When we come to the end here, we go back to the top. Is 3 less than or equal to 5? That's true. We print out the name. We add 1 to the count, making it 4. Okay, we come back down here and we say is 4 less than 5? That's true. Print out the name again. We will add 1 to the count. 4 plus 1 is 5. Okay, we come to the ending curly brace. That means we go back. Is 5 less than or equal to 5? That's true. It's not less than 5, but it is equal to 5. So we print out the name one last time. Okay, we add 1 to the count, making it 6. The flow control gets here. That means we go back to the top. Is 6 less than or equal to 5? This is the first time this is false, and the flow of control is going to pick up with the first statement beyond that block of code. And you'll see my name get printed 1, 2, 3, 4, exactly 5 times. Okay, here the physical order of the statements is different than the logical order that the statements are executed because we're looping back on the code. The logical order is a little bit different than the physical order. Okay, so these few statements also cause my name to be printed many times, but since there are fewer actual statements, the resulting executable is smaller. So this is true even if remember before I was talking about, well, what happens if I want to print my name, let's say 5,000 times? Well, the size of the executable will be exactly the same. Okay. This was not true when I was copying and pasting. So now notice that you can't see them all, but that's my name 5,000 times on the screen. And really the program, the executable program, is exactly the same size. I just changed this one number. Okay, so that's a really good reason why we might want to include a loop in our program, is it just results in less code that we, the programmer, have to write. Okay, so let me assign some names to these things here. So this thing right here we call the loop test. So when you hear me talk about a loop test, that's really the logical expression that's being evaluated. And this is always in parentheses next to a while. Okay, then we have these curly braces indicate where the loop body starts. Okay, so every one of your loops should have an opening and a closing curly brace. To indicate where the loop body starts and ends. And remember, when the loop test evaluates to true, the entire loop body is executed. Okay, so from top to bottom. Only when the flow of control gets to the bottom here do we go back and reevaluate that expression. Now when we go through the entire loop body, we call that an iteration. Okay, so every single time we go through the loop body, that's an iteration. And the types of logical expressions are exactly the same as with the ifs, meaning we can use Boolean variables. Those are variables that can hold only one of two values, true or false. Relational operators, the less than and greater than and equals. The logical operators and, or, and not. Okay, so all of the same stuff we talked about with ifs applies to loops as well. Now there are two types of loops. There's count-controlled loops and event-controlled loops. So with a count-controlled loop, one can determine how many iterations there are going to be before the loop even executes. In other words, you can tell how many iterations there are going to be just by looking at the code. With an event-controlled loop, we can't tell just by looking at the code how many iterations there are going to be. It all depends on either an event happening or not happening inside the loop. Okay, so let's look at count-controlled loops. This loop is an example of a count-controlled loop. Count-controlled loops have these things called loop counters. Okay, so this variable called count is a loop counter, and they keep track of the iteration number. Okay. It's very important that you remember to increase the value of the loop counter at the end of every iteration. And this is such a common operation that increasing a loop counter by 1, there's some special syntax that make it really easy for us to increase the value of an integer by 1. And that's using the ++ syntax. So this line here, count is equal to count plus 1. This can be shortened a little bit to just count and then 2 plus signs next to each other. And basically these two things are exactly equivalent. This will go find the variable called count and increase it by 1 and store the new value inside the variable called count. So normally when we assign a value, we need this single equal sign. That's the assignment statement. But when you say count plus plus, that kind of does all of this stuff in one concise statement. Okay, so count plus plus, that just increases the value of the counter by exactly 1. If you forget to increase the loop counter, you have something called an infinite loop. Okay, so let's go back to the code here. Let me go back to making that 5. And again, like I said, we can change this to count plus plus, and this should print my name exactly 5 times. But if I forget to do that, okay, so I commented it out. If I run the program now, okay, we see my name is getting printed over and over and over and over again. Okay, this is called an infinite loop. So an infinite loop will execute as long as the computer is running and has power supplied to it. So we could sit here all day, all month, all year, until this machine actually dies of old age. This program would continue to run and print my name. So infinite loops are very bad. Okay, you don't want to ever have an infinite loop. So if you ever do find yourself with an infinite loop, you can hit Control-C, will kill your program, and then you can go back to your editor. Okay, another thing you shouldn't forget to do is don't forget to initialize your counter. Right? So I could have done this where, yes, I still declared the counter, but I forgot to initialize it to an initial value. So if you forget to initialize the loop counter, it's going to hold a garbage value, maybe some gigantic negative number like -1 billion. Okay, since our loop tests to see if the counter is less than 5, and it increases the counter by 1 each time, this is going to cause my name to be printed a whole lot of times. So I don't know exactly what's going to be inside counter. Notice here it called this a debug error, and the message is the variable count is being used without being initialized. That's absolutely right. Okay, I've declared this counter and I'm comparing it against this number, but I have not initialized it. So in the old days, that program would have compiled and run. It just would have run, for a very, very long time. If that initial garbage value, if the value inside count was a gigantic negative number. But that garbage value might be some really huge number, like +1 billion. In which case, my name wouldn't be printed at all because 1 billion is not less than or equal to 5. So we would have skipped the loop body altogether. In either case, very bad things happened. Okay, so you always want to make sure to increase your loop counter, and always you want to make sure you initialize the loop counter to some value that makes sense. You can always determine how many iterations a count-controlled loop will have by performing this calculation here. Okay, so what's in the box here says the largest number that makes the loop test evaluate to true. If you subtract the starting value of the loop counter and add 1, that will give you the number of iterations in a count-controlled loop. So here's a little bit of code that we could apply this to. So we're supposed to take the largest number that makes the loop test evaluate to true. So count, what is the largest value that count that will make this thing evaluate to true? I think that's when count is equal to 10. Right? And then we subtract from that the starting value. So count started at 5. And then we always add 1. Okay, and if you do the math here, 10 minus 5 is 5, plus 1 is 6. So what this tells me is there will be exactly 6 iterations of this loop. And what I suggest you do is just count on your fingers how many times my name will get printed out. And you'll see it really is 6. Right? So when count was equal to 5, 6, 7, 8, 9, and 10, those are 6 iterations, okay, that would happen. Okay, so you can do this for any count control loop that's kind of moving upwards. You can use this calculation. As you can see from this example, the counter does not always have to start at 1. It can start at any valid integer value. Also, the counter can move down rather than up. So here's an example where we start the counter at 5, and we say while the count is greater than or equal to 1, and then instead of doing a plus plus down here, we do a minus minus. Okay, and as you might expect, that decreases the value of the counter by exactly 1. Okay, so let's look at a kind of a classic example of a count-controlled loop. So I'm going to write this program, or copy and paste this program, that's going to find the sum of the numbers from 1 to x, where x is going to come from the user. Okay, so that's the goal. I'm gonna kind of build this program up in a couple different steps. Because the goal again is I want to, let's say I enter in the number 3. I want to sum up the values 1, 2, and 3 to find out what the sum is. Or if these are entered in 5 for top number, I want to sum up 1, 2, 3, 4, and 5. So the first thing I want to do is I just want to make sure my loop will give me those values 1, 2, 3, 4, and 5. So I have this variable called top number, and I prompt the user to enter in the top number. Then I have this count controlled loop with my counter. Here I call it counter. I set it equal to 1. And I say while the counter is less than or equal to top number. Okay. For right now, what I'm going to do is just print out counter, because I'm curious to see, well, will counter actually hold all the values from 1 up to and including the top number? So the best way to do that is just to print it out on the screen and see, are those the numbers I'm expecting? So if the top number is 10, I hope to see on the screen 1 through 10, and that's exactly what I see. Okay. Now I can start to think about actually summing up these numbers. Okay, so I'm gonna add some code here. Which is really based off the code I've written here. Okay. And this is something I do all the time. I do pretty much all of my code in tiny little steps. Sometimes I call them baby steps. So I want to make sure that the first part of the program, I wanted to make sure the counter actually was going through all the values like I expected. Now I have this additional variable called sum. And sum is going to be used to hold the sum. Okay. Now that I know the counter really is going to go from 1 up to and including the top number, what I can do is start adding whatever's in the sum to the current value of the counter, whether it be 1, 2, 3, or so on. So sum has to start at 0, And then here, again, we always do the right-hand side of this assignment statement first. So 0 plus 1 is 1. The next iteration counter will be 2. 1 plus 2 is 3. The next iteration counter will be 3. So 3 plus 3 is 6, and so on. Okay. So if I run this, and I type in the number 10, the sum of the first 10 numbers is 55. And you can, again, get some pen and paper out to prove that to yourself. I could put a much bigger number in here, so maybe 100. And the sum of the numbers from 1 to 100 is 5050. Again, I believe that's correct. Okay, so that's kind of a classic count-controlled loop where we're counting how iterations iterations there are going to be, and then we do a little bit of arithmetic. In this particular case, we do a little bit of arithmetic inside the loop to sum the numbers. And of course, at the bottom here, we have to print out the results. So sum is going to hold the value of all those counter values from 1 up to and including top number. So we can print that out down here. Okay, so that's a count-controlled loop. The other type of loop is called an event-controlled loop. And with an event-controlled loop, the loop exits when something happens. An event occurs while the loop is running. The event might be a value entered in by the user, for example. Okay, so I have another program here we can look at. Okay, so I have declared this variable called continue processing, and I initialize its value to be the letter y. So remember, characters hold individual letters or numbers or values from your keyboard. Okay, now I have this loop that says while the variable continue processing is equal to the letter y, this is the comparing for equality, not the assignment statement. Well, then we're going to do something interesting. Maybe I'll see out something interesting. Okay. But then after something interesting happens, we prompt the user, well, do you want to continue? And they're supposed to type in a capital Y for yes, and anything else will mean no. Okay, so we read that in, and then we get to the ending curly brace. That means we go back to the top and evaluate the expression. If they did enter Y, then we'll do something interesting again and again and again. All right, so we just did something interesting. Do you want to continue? Yes. Do you want to continue? Yes. All right. Eventually I might say, no, I don't want to continue anymore. Okay, and that's when the program's going to end. Okay, so here you can't just tell by looking at the code how many iterations there are going to be. Right? If I ask you to look at this code and tell me how many times it's going to iterate, you don't really know. It all depends on what happens while the program is running. And that's kind of the classic example of an event-controlled loop. You have to wait till the program's running before you can figure it out. And sometimes the event comes from the user, but sometimes events can be generated by computers or other systems. Okay, so it's not always, the event doesn't always come from a human, but it can. Okay, a few other things about loops. We can nest loops together inside one another. So let's look at another bit of code. Okay. So eventually what I want to do here is kind of print out 10 rows and 10 columns worth of numbers. So basically from 0 to 99. Okay, again, I'm going to do this in 2 steps. I'm going to start with my outer loop. This is eventually going to be my outer loop. So I know I want to print out something 10 times. So from 0 to 9, that's actually 10 individual items. Okay, but now I'm going to add another loop inside that first while. Okay, so we had counter 1. Kind of our standard count-controlled loop. Okay, so we still have counter 1. Okay, counter 1 is less than or equal to 9. That's exactly what we had before. Now I have the second variable called counter 2. And the first thing inside the loop body of the outer loop, I'm going to set counter 2 equal to 0. And then I have the second while loop that says is counter 2 less than or equal to 9. Okay, if that's true, we're going to get inside here, and I'm going to print out counter 1 followed by counter 2 and a space. And then I'm very careful to remember to increase the counter 2 inside the inner loop. And of course, I still have counter 1 plus plus. That still should be the last thing that happens inside the outer while. Okay, so if you run this, this is what you should see. We have 10 rows and 10 columns where our basically row and column number get printed out from 00 to 99. Okay, this can be really powerful. You can do a lot of work with just a little bit of code. Let me show you another program. This is going to have 3 nested loops. And I usually don't go more than about 3 loops deep because it starts to hurt my brain a little bit. Okay, so here I have 3 counters, counter 1, 2, and 3. So the outer loop is going to execute 1,000 times. And part of the outer loop's body is this loop that's going to do another 1,000 times. So 1,000 thousands is 1,000,000. And inside this loop that's going to execute 1,000,000 times, we have another loop that's going to execute 1,000 more times each iteration. So 1,000 millions is a billion. Okay, so this code in here, in the innermost loop, that's going to execute 1 billion times when this program runs. And we're going to see it takes about a second or two for the computer to actually go and sum up the numbers. Oh, I think I forgot to see out the sum. Okay, so let me do that again. It takes about 1 or 2 seconds. And it prints out the sum is actually 1 billion. Okay, and look at that. That's not even 10 or 12 lines of code. But I've just told the computer to do something 1 billion times. Okay, that was quite easy with a loop. It'd be very difficult without a loop to copy and paste or to actually write 1 billion statements. Okay, lastly, if you would ever like to interrupt a loop to exit it, you can use the keyword break. So one last program here. Okay, and what this program does is, again, it's our standard, it's going to print my name 5 times. But notice here I have an if inside the while. That's perfectly legal too. So when the flow control gets here, we check to see, well, what's the value of count? If it's equal to 3, then we're going to go inside here and execute this break statement. So when count is equal to 1 and 2, and the flow of control gets here, this is going to be skipped, because this is not true. Okay, only when count is equal to 3 are we going to come inside here. And break is going to find the closest loop that we're inside, and the flow control is going to pick up immediately outside that loop. So, as you expect, we're going to see my name exactly 3 times. Okay, why 3? Well, when count was equal to 1, we printed my name. When count was equal to 2, we printed my name. When count was equal to 3, we printed my name. Only after we printed the name do we check to see if count is equal to 3. Then that was true, and break brought us to the first statement outside the while. And notice we didn't see the 4th or the 5th iteration because we broke out of the loop. Now break only works with loops. You cannot break from an if. Break is a loop-only type thing. Okay, so that's the basics of looping. Our next video is going to cover these things called for loops, which are basically exactly the same as a while loop, except the syntax is a little bit cleaner for us programmers to write.